Hi. It's just going to be a quick one today as I'm still working flat out working on the Loopy update and a few other things. But I wanted to share a win that I've just had with you that I'm rather pleased by. So we discovered last week that the iPad Air 2 and the iPhone 6 are doing something a little bit strange with audio. See, just for some background here, multi-threading computers work by kind of devoting a little bit of attention to different tasks one after the other. That's called scheduling. So just the way that you go about your day, and you might do a little bit of counting here, and well, if it's a bad day, and then you'll devote some attention to your coffee, and then you'll devote some attention to playing with your kids. You're kind of sharing your attention out among the tasks that you have to do. The same thing is true of computers. So threaded applications work the same way, where you have an audio thread that will generate audio, then you'll have a thread that will do some video rendering and a thread that will handle user input like taps and that sort of thing. And the CPU kind of focuses its energy on one thing at a time. Multi-core CPUs, like the ones that are in the newer devices, can actually do more than one thing at a time, but the concept is basically the same. So there's your primer on multi-threading. Now, we've just discovered that the Air 2 and the iPhone 6 behave a bit differently to older devices with respect to how they prioritize the audio thread. So with Core Audio, that's the system that handles audio on iOS, there's a thread that is just for doing the rendering of the audio. For Loopy, for example, that thread will look at the in-memory audio chunks, and it will sequence them depending on where you are in the timeline and then play them out. So on older devices, that thread is a real-time thread, which means that it gets top priority. So if it's busy, nothing else is going on. At least that's a guess. We don't really know for sure, but that is apparent. It seems to be how it behaves. So if there's another thread that's busily rendering an animation, for example, it doesn't affect the audio thread. And that's kind of a good idea, because if you run out of time to generate a particular chunk of audio, you're not going to be able to play that audio in time, and you'll get a glitch. That's where you get glitches on iOS. It can't sort of provide audio to the audio system fast enough. So basically, in Audio Bus we have the buffer duration setting, which ranges from very low latency but high CPU load, and it doesn't give you much time to generate the audio before you get a glitch. And it goes all the way up to 1024, which is quite high latency. It's about 100 milliseconds, but that gives you a lot of time to do the rendering, so you get nice smooth audio even if you're doing quite a lot. So that's audio. Now what the Air seems to do, and the Air 2 and the iPhone 6, is it doesn't seem to be real time. It seems to actually, when you're busily doing other things, it actually diverts attention away from rendering audio to do the other stuff. And I've discovered all you need to do is have an animation on screen, and it'll double or even triple the amount of time it takes to generate the audio, because it does a little bit of generation, then it goes and services the animation thread, and then it comes back and does a bit more, and then goes away and does the animation again. So we've found that with the AudioBus app, there's an animation that runs the little light strip thing. When you've got an active pipeline, an active connection, you get the little chevrons flashing to show there's activity. Now that's an animation, and that actually triples the amount of time it takes AudioBus to render audio on these devices. So I had a great win last week by replacing that animation with my own code that would just run something like 10 or 20 times a second and just set the position of the animation. So it looks exactly the same, but suddenly AudioBus takes a third of the time to run, which means you can do a lot more with the same device with this new version. And that version is currently under review, or it's in the app review queue, so that'll be out soon. So I've devoted my attention to doing the same thing with Loopy, and I wanted to show you just how much difference it makes, because I'm quite excited about it. So this running right now is as it was before. That's close to the version that's on the App Store right now. And if I hit play, I've got oh, hang on. This is all wrong. Bear with me, I have to fix this. And go. There we go. that's better. Sorry, I had a flag set that causes the audio engine I use to report every second how long it takes to render, and that flag wasn't turned on in that build. So, okay, if I hit play here, you'll see I've got this code here which measures how long it takes from when the audio thread starts the time interval to when it's actually finished and it's got the audio ready to go. So Loopy usually runs at about 256 frames, which means that's 256 frames at 44.1 kilohertz audio, and you can get how long that is by dividing the first by the other. So we go 256 divided by 44,100. So that means the buffer duration is 5.8 milliseconds. Now, the system takes about 1.2 milliseconds of that. I've kind of just roughly measured that. So that means we've got about 4-something milliseconds in which to render before we get a glitch. So that's our kind of red line. Now, ideally, we want to stay well below that. So we budget for about half of that. So we'll say 2.3 milliseconds is pretty much, we don't really want to go much beyond that. Now, of course, the more time we take, the less time we have for other apps when we're using Loopy with Audio Bus. So the lower we can get, the better. And you'll see Loopy right now, and this is as it is on the App Store right now, is taking about 0.5, 0.6 of a millisecond. So that's a bit over a quarter of our budget. So it's okay, but as you'll see, we can do a lot better. So what I'm going to do now is I'm going to update to the very newest version after my fixes. So just do that here. So this is the work that I did today. And if we run it again and do exactly the same thing, same project, I'm just going to hit play. Let it run for a moment just to give you a proper idea. Yep, and you can see now it was taking 0.5 or 0.6 of a millisecond before, and now with a few simple changes, it's now taking 0.2. So that's 0.2, let's say 0.22 on average divided by 0.6, which is what it was before. So that's about a third of what it was before. And all I did there was I replaced the core animation, that's Apple's own animation stuff, with my own, which runs on a timer and just sets the position of the animation manually. And it looks the same, except it's a third of the weight that it was before. Now what that means is now you can have another 0.4 milliseconds worth of apps that you can run at the same time as Loopy, and you won't get glitches anymore. So I'm really happy with that. I think that's a great find. Now, this isn't necessarily a problem with the iPad Air or the iPhone 6. I haven't really decided how I feel about it, but it's something that is different, and so it was a bit of a surprise to come across. But knowing that it is the way it is, it makes it fairly easy to then get these great performance gains. So I'm pleased. Okay, well, I'm still at least a week or two off getting back to Masterpiece, unfortunately, but it's going to be worth it, trust me. So I will speak to you next week. Have a good week. See ya.